y'all struggled with the last one?
Yes.
Okay, I'll go back to 16. I've already started writing this one, so this is 18. Oh no. Okay. Oh my gosh. Okay. I'm going to try to get through this as quickly and painlessly as possible. Let you do your work so you're done, because today's lesson is really, really easy. Monday we will review. Tuesday we will test. I wasn't sure how many of you would be here today, but I'm glad to see all but 3 of us made it here today. Today's is really easy though. Today's lesson is really easy. We're going to do notes, but they're easy notes. It's just a little bit. All right. If I can reel you in, guys, and let's go over this quickly. I want to get this done quickly too, so I can get my lesson plans done whenever I'm finished and I can leave with y'all today. Okay. First things first, I always go through and do whatever I can wherever I can. I guess let's look at this fraction first, since it's the harder. This is a complex fraction, so I'm going to do the top first. So I have 1 over x minus 4 over x squared. What's the LCD there? X squared. So the only thing missing is an x for this one. And so I end up with x minus 4 over x squared. Yes? And then the bottom of this one, the only thing really I could do is rewrite x minus 4, x minus 4. And of course, this is over 1 if I'm thinking in terms of fractions. Okay? Now, what I'm going to do when I put them together is I'm going to do top times flip that bottom over. And the reason it's convenient for you to write that x minus 4 twice is now it's kind of easy to see that factor cancel out, that x minus 4 factor, okay? All right. Now, I have 1 over 4x squared times x minus 4, yes? All right. Oh no, why is it even doing that? Okay, now let's work on the other. So this is literally just this fraction. Everybody okay? All right, now let's look at the first one over here, and let's see what we can do with this one. I think I'm going to try to take out a 2x, and it leaves me with x squared minus 16 over x plus 4, which I hope you see is a what? Difference of squares. Oh my God. Okay. So I hope you notice the difference of 2 squares here, right? Which is 2x times x minus 4, x plus 4, and then the x plus 4. And this is one of those situations, we were doing this a little bit yesterday, where we simplify it before we even start to make our lives a little bit easier to deal with. So the x plus 4s are gone now. So I would say this fraction is better like that. Yes? Okay. So, okay. Let me see if I can zoom out a little bit so you see it all. So this one I am going to change to 2x times x minus 4 over 1, like this. Okay. And this is all one big fraction because I'm multiplying straight across. Everything is factored so I can start canceling out where I see common factors. So the x minus 4s are the same. 2 and 4 can reduce to 1 and 2. And then I've got an x and I've got 2 here, so I'll just take one of those. So it looks like I'm just left with 1 over 2x, and that's it.
I didn't get that.
You're welcome. All right, and then I think you asked for 17.
Yeah, let's go 16.
Okay. 16. For 16, I've got 2a over 9b minus b over 2a. This is the top. And this is, let's see, the bottom is a over 3b squared plus 1 over 2b. All right, so let's look at the top as its own problem first. What's the LCD here of the top? The LCD is 18AB. So what does the first fraction need? 2A. What does the second fraction need? 9B. So I end up with 4A squared minus 9B squared over 18AB. Now, what do you notice about the top of that fraction? What do you think, Harris? It's a difference of 2 squares. That's exactly right. So how does it factor? 2a minus 3b times 2a plus 3b, right? Over 18ab. I'm done with the top. I'm going to move on to the bottom. All right, for the bottom, what's the LCD? 6b squared. What's the first one need? A 2. What's the last one need? A 3b. All right, so I got 2a plus 3b over 6b squared. Yes? Can't factor anything, can't do anything else, so I'm just going to move forward with, and this is where Gina was saying she gets confused sometimes about when to flip and when not to flip. And it does get confusing because you get so used to flipping that then whenever you don't have to flip, you think you're doing something wrong, right? But I do need to flip here because it's a big fraction, right? I'm dividing. What I'm really doing is this divided by that. So I'm going to change it to multiplication and flip. So I got 2a minus 3b times 2a plus 3b over 18ab times, and I'm going to flip this fraction over. What cancels? The 2a plus 3b. Anything else? Divide by 6. That'll leave me a 3 there, and take a b away. Anything else? That's it. So I got 2a minus 3b. I've got a b left over 3a.
Anybody mean 17? Okay.
But everybody around you might not have.
No.
17. 17. How do you know if you got it? You just remember? How do you know if you got it right or wrong? You just memorized the whole sheet? All right, right, let's do top first. Top. What is the LCD? Just x. So I just need to give this guy an x, and I end up with x to the third plus 1 over x. It's a sum of cubes. Look at y'all go. Harris, you're not going to know how to do this. Stop bumping your gum. So I wonder why you don't have your paper or your pencil out. No. All right, so the bottom I really can't do anything with other than maybe writing this as x plus 1 twice. So I'm going to go ahead and flip this and multiply.
Yeah.
Guys, I have lots of chatter and it's hard to concentrate. I don't ever mind going over homework as long as you need it, but if we don't need it, I'd rather not. You can't, it was x plus 1 squared, so I wrote it as x plus 1, x plus 1, so that I could cancel that there. You better not have distributed that exponent. Ah.
So that's why I got x plus 1 at the top.
Yeah.
Wait, why don't?
So x plus 1 squared is not the same thing as x squared plus 1, because if you FOIL it out, you will see that it's actually x squared plus x plus 1. So it's actually x squared plus 2x plus 1, which is not the same thing. If you're ever adding or subtracting in the parentheses, it never distributes through. Only when you multiply or divide.
Oh, so this is the shortcut? I don't understand.
No, I was saying you can't do this. How can I FOILed it? Right. The exponent just tells you how many times to write it. Right. All right. Let's switch gears. Get our shovel. I know. We'll do some snowy freak out.
But if it's not,
We can keep that away. I'm sorry.
I have to buy me a pair of shoes every year. I just want to like my hair.
You get a coffee break, but we get a snow break.
When they ask me, I thought they were like, sometimes when I'm walking, my hands freeze, so sometimes I have to get my gloves.
Last lesson of the unit. So today's lesson I think is the easiest of the lessons of the unit. Yes, I'll be happy to. You're welcome. Huh? Can we what? What y'all say? Possibly, actually. So there's different methods you could use to do this. If you think back to whenever I don't know what grade you learned proportions, where you have something like this, and you did butterfly, where you cross multiplied and did all that. I'm not even going to go that far into this. I'm going to teach you one way to do this. I think it's the easiest way, and I think that I call it the LCD method, but I don't know what the real technical name for it is. But here's what you have to remember. Now, this time we're talking about equations, which means I have an equal sign, which means I'm trying to find an x value. I'm trying to solve it for x, right? But I'm talking about rationals. So I've got all these fractions added, subtracted, equals to something, and I have to solve for x. For example, maybe something like if I asked you to solve that for x, what would you tell me? You'd probably tell me I'm crazy, right? So, but we're going to get to that. What the point that I'm getting to is that this looks a lot worse than it actually is. If goodness, Stacy, fall on the course, please, right in front of everybody. If you can force everybody to have the same LCD, okay? So every single fraction in your equation, in this case, there's 1, 2, 3 fractions. If I can force them to all have the same LCD, then what I can do is I can drop the denominators and solve using only the numerators. It's really satisfying to do. Okay, so solve using only numerators. So yes, it does involve some factoring because to find the LCD, I need the factored forms of these, right? So I'm going to go through and I'm going to factor everything first, okay? Look at the first fraction. Can it be factored? Nope, already factored, right? Look at the second fraction. Yeah, that one can be factored, right? In fact, I can shortcut it because it's a 1 in front. So how does that one factor? X minus 5, x minus 2. Look at y'all professional factorers. Okay? 2 cannot be factored any further. What is the LCD of everything? So LCD from start. Okay. X minus 5, x minus 2, and then just a 2. Is anybody confused on that? Okay. Make everybody have the same denominator. Okay? Whatever you have to do. So look at the first fraction. What is it missing? X minus 2 and 2. Do we see that? Okay, so this one needs an x minus 2 and a 2. I have to give it to the top and the bottom. What's the second one missing? A 2. I give it to the top and the bottom. What's the last one missing? X minus 5, x minus 2. 5, x minus 2. Once I'm in this scenario where all the bottoms are exactly the same, drop them. Literally drop them. Don't do anything with them. And rewrite the numerators. So look at the numerators. I've got 2 times x minus 2 equals 2 minus is that an equation you can solve? Yes, it's going to take me a little bit of manipulation and working with it, but that I can solve, especially opposed to the first. So what are we going to do to solve this? I think I would expand it out first. Is that what you said? I would FOIL and distribute first. So I'd come over to this side, and I would distribute. So I got 2x minus 4. Yes. I'm going to FOIL, and be careful of signs like this, because what I'm doing is subtracting every bit of whatever I FOIL out here, okay? So I'm going to put it in a big bracket here so I remember. So x squared minus 2x minus 5x. Now, y'all are in pre-cal now, so if I skip this step, are y'all okay? And just write minus 7x. And then plus 10. It's also already there from the beginning. That's right. That's what we started with in that second fraction. Okay? So now what I have is 2x minus 4 equals 2 minus x squared plus 7x minus 10. Now, back to algebra 2. How do you solve a quadratic? Because that's what this is. It's a power of 2, so it's a quadratic. What do? Make it what? Equal 0. Make it equal 0. Always make a quadratic equal to 0. Okay? Get everything on the same side, preferably my leading coefficient being positive. So which side should I move to? To the left side, right? Because I want this one to be positive to make my life easier. So I'm going to take everything from the right and move it to the left. Okay? All right, so I'm going to add x squared. Again, I hope I can do this all at one time. I don't want to confuse anybody though. Minus 2 and plus 10. Somebody's got a phone on and it's supposed to be off. Keep hearing it. I can't do that? Oh. Oh. All right, we very well might have to. All right, so I've got x squared minus 5x. Then I've got negative 4, negative 2, and positive 10. Should be 4 plus 4. How can I solve that? Factor. I would always factor, or slash if you can. This is a nice shortcut one that I can shortcut because it's the leading coefficient of 1. So how does this factor? X minus 4, x minus 1. Give me the values of x here. Mm-hmm. Yes. Yes. If you got it, I'm going to go ahead and pass these out. If you don't, I'm going to sit up here and do several more with you. But I don't want to hold anybody back from I'm caught up in chords here.
Yeah, I got it.
All right.
How's the papers?
Yeah, we'll probably just do them in class. Most of them, that's as hard as it gets, is the one I did. Most of them are not that involved, yeah. In fact, I'll do one of these with you. All right, pick one from the homework sheet. Doesn't matter to me, pick one. 16. Yeah, but they really don't take as long as you think. I promise you they don't. You'll finish before you leave. You'll finish. You have over an hour. You'll finish all before we leave. Huh? I don't know. That's what they asked for. Okay, give me another one. Give me another one now. All of them?
Listen, the one we just did took a long time.
You need another one? Yeah. All right. Look over them. Look, I'll do one from the front and one from the back. How about that? All right. All right. You're just assuming that they're harder as you go. All right, number 8. I've got x squared plus 2x minus 15 over x equals x minus 1 over 2 plus x minus 1 over x. What is, actually, let me go ahead and factor. We will, but yeah, you will. So you don't want, okay, so we'll just factor denominators then. How about that? So my LCD here is what? 2x. What's the first one need? A 2. What's the next one need? An x. What's the last one need? A 2. Are all the denominators the same? Drop them. No, because then she's right. Then we'd have to go back and only do the denominators. All right, so I got 2x squared plus 4x minus 30 equals, and I'm just going ahead while I'm here and doing all this. Yep. Equals what? X times x, x squared minus 1x, right? Plus 2x minus 2. Combine some like terms. If you want to combine them, I'm probably just going to combine them as I move, but you can combine them now if you want to. If you want to make this plus x, that's fine. So should we move to the left or the right? Because this 2x squared is here. Yeah, we want to move everything to the left. So I'm going to subtract an x squared. This one over here on the right. I'm moving the right to the left. Over here on the left. Yes, we will. I'm just doing it all at one time, and I'm going to subtract an x and add a 2, because remember, I want it to equal 0. Am I skipping too many steps for y'all? 2x squared minus x squared, x squared. 4x minus x plus 3x, negative 30 plus 2. Shortcut, what multiplies to negative 28 but adds to 3? 7 and negative 4. So plus 7 minus 4. What does x equal? Good. See how quick that was? That literally took us 3 minutes. What's 3 times 16? Actually, 3 times 15 because I just did one. 45. Got an hour left. All right, and one more. Flip over at the back. Which one you think? Doesn't matter to me. Pick one. What factors, denominator-wise? That last one, negative 5 and positive 1. What's my Harris? I am fixing to move you up here with me. What's my LCD? What's the first one missing? X plus 1. What's the second one missing? X plus 1 again. What's the last one missing? Nothing. Are all the denominators the same? They are. I'm ready to drop them off. X minus 3, X plus 1, minus X plus 1 equals 6X minus 12. Will you always get quadratics for these? No. A lot of times, yes, but not for every single one. This is another quadratic. Tell me what to do. Before even I move it, what do I need to do? Foil. I gotta foil it, right? Bless you. I have x squared plus 1x minus 3x gives me what? Minus 2x minus 3 minus x, but also minus 1 because that negative sign has got to distribute through. Okay. Clean up that left side a little bit. Negative 2x and negative x is negative 3x, and negative 3 and negative 1 is negative 4. Now what? Make it equal 0. Take it all over to the other side. So I'm going to subtract the 6x and add the 12. I have x squared minus 9x plus 8. Shortcut. X I added 12. It was negative 4 plus 12. What does x equal? 1 and 8. It's not the new stuff that's going to stump you. It's going to be the algebra 2 back there with all the factoring and solving that way. The new stuff is just getting the LCD and dropping the bottoms. The old stuff is solving.